My name is Joachim Aertebjerg. I'm a technical director for the EMEA territory at Intel.
Fantastic. So now with mobility going out of bounds, with the use cases going out of bounds, what's happening in the compute area in terms of computing, the application, streaming, all the other multiple use cases happening in the digital devices?
Well, as you can see here, Gitex, right, the technology revolution, it hasn't stopped, right? It continues to innovate, at all fronts, right? So what Intel is very proud to present here with partners is intelligent solutions at the edge, right? That will enable a lot of Internet of Things, that will help us do smart things in the future, right? And also smart devices that are used both in laptop formats, but also in wearables, and then all the way to the data center. And specifically, we are demonstrating with our partners some new accelerated data and artificial intelligence solutions based on new memory technologies.
Fantastic. So tell me, this form factor you just mentioned for wearables, what is this new form factor PC you're talking about?
Right. So with NNTC, we're fortunate to help support a project that is really enabling a wearable device, right, that can help in safety and crowd control use cases, basically. And that is based on a visual image that is, as I said, worn inside the glass, and that is based on computation that happens on a wearable PC. Inside that wearable PC is the Intel processors, of course, but also increasingly new memory technologies, persistent memories that allow faster data processing and more data capacity.
Can you explain this a little bit more? I think the use cases are quite obvious for this. But what exactly is the best use case for persistent memory?
Okay, so persistent memory really well for databases, right? Databases growing very fast. Data is collected all over the place now, so the databases are growing. Enterprise resource planning, right? The so-called type of SAP type solutions, how you manage your business with inventory and suppliers and all that is also growing and getting more interactive, right? People use Twitter feeds, to mix it in with their enterprise planning, right? So that is also a place where you want fast response times on data and the databases, and persistent memory can help that because they can keep more of the data closer to the processing unit, right? So those are classical, more back-end solutions. But in terms of client solutions, if you have a laptop, you really want it to boot up really fast, right? So if you imagine that the entire workload in the operating systems and what you worked on last, the presentation and whatever, is in the memory. So when you open it up, boom, it's there.
Are these already mainstream? Is this compute available for mainstream usage?
So the new obtained persistent memory from Intel is available in the data center, and it's increasingly coming in laptops, and will also find its way into wearable computers or various.
Coming back to the wearable glass we just talked about, in that it's a trick between the human eye seeing the normal vision and two other images happening, two other streams happening at the same time. One incoming where there's a capture and one the relay back. Does the application developer have to take any significant IP from you to understand how to structure the application?
So Intel is predominantly a hardware vendor. We do have software tools that we also make available to the ecosystem, like NNTC, that they then develop the application on. In this particular solution, the IP is predominantly with NNTC.
But does your compute stack need to be architected in the way they structure the application, how these signals move? Is there something they need to look at, leverage from you as an alliance partner?
So applications are increasingly abstracted from the hardware, right? And programming languages are also higher level than they were in the past, right? But the more optimization you get for the entire solution stack down to the hardware, the better the performance. And in a wearable solutions where you have power constraints, and therefore also computation hardware constraints. You don't want the headset to be too clunky either. So you really need smart programming, and that's where local software development and the IP that they develop comes into play.